So this is a little video on line of best fit. Why would we use line of best fit? So we would actually use this for a situation where our data looks like it could be somewhat linear, but it's not perfectly linear. So for example, if you look at this, you can see that we don't exactly have perfectly linear data, but a line would actually be a nice model for it, because if I wanted to make a future prediction about what was happening, I might be able to use this equation to say, well, if this is about what's happened so far, I could actually predict into the future what might happen. So let's do an example together for a line of best fit. The first thing that we're going to do is, once we have our data, put this around. Once we have our data, we're going to want to graph it, right? So we know that this is our independent variable, or x, and this is our dependent variable. So I'm going to want to set this up. So I'm going to go, I think I can go by ones here for hours because I have quite a few lines. So I'm going to put hours down here. We've got 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I go on out, and then that's hours, and then I want to put the commercials up here. The number of commercials that maybe people would see when they're watching TV. So I'm going to go up to 66. So I need to probably go, I think I'm going to go by fives here. Should make it up. So we got 10, 20, 30, 40, 50, 60, 70. Okay, so here we go. I need to actually plot my data. So at 1, I'm talking about 5. That's nice there. And then 2 is 11. 3 is 16. So it's a little more than 15 here. They actually don't have one for 4, so I'm going to skip right over here to 5 is 29. Okay, 7 is 39. Okay, 11 is 62. Probably about there. And then 14 is almost, let me see, 60, that's 70. Oh, here's 65. Okay, so there we go. This point looks a little low, but that looks like it was what it was intended there. So we can see that it's not exactly linear, right? But again, like we talked about, I feel like a line might be a good way to model this data. So what we want to do when we make the line is we want it to kind of be in the middle and not very far from each of the dots. So I kind of want to say, all right, well, I know that I could put all the dots below or all the dots above. I don't really want to do that. I want to kind of come somewhere in the middle here. So I'm feeling like this might be a good spot. This one maybe would be a little below, but I'm feeling like, let's see how this looks. And we can always change it. Okay, so I'm actually hitting several of the points down here. That's really good. It looks like I'm kind of splitting the difference for some of those. So I think that's probably a decent line. All right, so now I need to find the equation of the line. So the first thing we want to do, remember, every equation is going to have our y-intercept, where it crosses the y-axis, and our slope, or rate of change. So I need to find both of those things to make my equation. So the first thing I'm going to look for is going to be our start number. So I'm going to do y equals, our start number is where it crosses on the y-axis. And this looks like, it's hard to tell, but it looks like it might end, if this is 5, I might be able to call that 1 or 2. I'm going to make that 2. So y equals 2. Now, to find the slope, remember, I want to find the rise over the run, or the change in commercials per hour, how many commercials there are per hour. And this is where we have to be very, very careful about scale. So I want to look at my line, and I want to find either two good points on that are actually on the line, or two good places on the line, even if they're not actual like coordinates that are part of my equation up here. So I'm going to find two that are on the line here. So I'm going to pick this one, which is 7 and 39. And then I'm also going to pick this one right here maybe, which is at 3 and 16. And I know because those are two values in my table. So if you pick two values that are in your table, then you can actually just use the table up here if you wanted to. And you could say, all right, well, I know how much it's increasing in this case, it'd be every 4. You know, you could use this to help you, just like we do with tables. But what we could do is we could use the graph, and that's what I'm going to encourage you to do. So remember, we need to find the rise over the run for the slope. The slope, we always say, is the rise, the change in y over the change in x. So the number of commercials compared to the number of hours. All right, so if I'm here, which I'm at 16 here, that's important for us to note, then I'm going to go up until 39. I'm going to rise from 16 to 39. So how much am I actually going up if I go from 16 to 39? I'm going up 23. All right, so I'm going up 23, and that is not per commercial. That's from 3 hours to 7 hours. So I'm going up 23 commercials. There was 23 commercials in a time span of 4 hours. So I can say that there were 23 commercials for 4 hours. That's kind of an unfortunate rate of change, right? Now I'm looking at something that's kind of ugly. But I can actually just kind of find an average. If in 4 hours I see 23 commercials, I can do 23 divided by 4, and I can get 5.75 as, sorry, there should be an X next to it, per hour. There's about between 5 and 6 commercials per hour, which kind of makes sense because look, if we go back up to our table, this one up by 6 for an hour, this one up by 5 for an hour. I had 5 commercials in that hour. In the next 2 hours, here, I had what? 13. So that's, 6.5, right? So we're finding values that are somewhat close to 5 and 6. So this does make sense as a situation. Now they might ask us, hey, in 20 hours, this would be 20 hours. In 20 hours, how many commercials would you expect to see? So I can do that in 2 ways. I can either extend my line, keep it going all the way up to 20 hours, and extend my graph, or a simpler way might be to use the actual equation. So I'm going to say y equals 2 plus 5.75x, and x is the number of hours. So I'm going to plug 20 in, and I'm going to multiply that by 5.75, because that's how many per hour, plus the 2 from maybe before I started. So I end up getting 115 plus 2, which is 117 commercials. And that's how many I would expect to see. So you're using your line to make a future prediction. All right, good luck with your line of best fit.